Ever wondered if the moon landing was a hoax, or if black holes are actually massive cosmic vacuum cleaners? Well, you're not alone. Our universe, with its seemingly infinite expanse and endless mysteries, has always been a fertile ground for myths and misconceptions. From the dark side of the moon harboring alien bases, to the belief that there's absolutely no gravity in space, these captivating narratives have fueled our imaginations for decades. Some of these myths have even been etched so deeply into our collective psyche, they're often mistaken for facts. But today, we're setting out on an interstellar journey, a quest for truth in the vast cosmic ocean. Armed with science and reason, we'll debunk these popular space myths one by one. So buckle up, space explorers. It's time to leave the earthly confines of misinformation behind. Let's dive into the cosmos and separate fact from fiction. First off, the ever-popular myth. The moon landing was a hoax. This story has been buzzing around for decades, ever since Neil Armstrong took those legendary steps on the lunar surface back in July of 1969. Many believe that the moon landing was a grand orchestration by the US government to assert dominance in the space race against the Soviet Union. They claim the lunar landing was shot in a secret Hollywood studio, with every detail meticulously staged. Now let's delve into this myth's origins. The conspiracy theories started to gain traction in the early 1970s, when a self-published book by Bill Kaysing, a former US Navy officer, suggested that NASA lacked the technology to land humans on the moon. His argument was primarily based on perceived anomalies in the Apollo footage and photographs. This myth has remained popular due to its sensational nature. The idea of an elaborate hoax involving the government and the media is intriguing, to say the least. It feeds into a broader narrative of mistrust against institutions, and serves as a compelling story for those who are skeptical of official narratives. However, the moon landing hoax theory crumbles under the weight of scientific facts and evidence. For starters, we have physical proof: moon rocks. The Apollo missions brought back over 800 pounds of moon rocks, which have unique properties that can't be found in Earth rocks. Moreover, the technological capabilities of the time also debunk this myth. In the late 1960s, while special effects existed, they were nowhere near advanced enough to fake the moon landing footage. The movement of astronauts in a low-gravity environment, the detailed surface of the moon, the reflection and shadows, these were beyond the reach of the technology of that era. So, the moon landing? Definitely not a Hollywood production. It was a monumental achievement of human ingenuity and perseverance, a testament to our innate drive to explore and understand the universe around us. Scene script. Next up, black holes, the cosmic vacuum cleaners. Now that's a phrase that's been floating around in popular culture for quite some time, but let's set the record straight. Black holes are not cosmic vacuum cleaners. They aren't out there, hungrily hoovering up everything in sight. This is a common misconception, and it's time we cleared it up. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. They form from the remnants of massive stars that have undergone a supernova explosion. But here's the thing, even though their gravitational pull is incredibly strong, it only affects objects that come really close. Imagine you're standing on the surface of a planet, and you throw a ball. If you throw it gently, it might land just a few feet away, but if you throw it hard enough, it'll escape the planet's gravity and fly off into space. Black holes work in a similar way. They don't suck in objects from far away. Instead, objects have to come pretty close to the event horizon. That's the point of no return, before they're pulled in. So, if our sun were to suddenly become a black hole, don't worry, it won't, it's not nearly massive enough. The planets wouldn't get sucked in. We'd still continue to orbit around the black hole, just as we do around the sun today. It's also worth noting that black holes aren't invisible, as is often believed. They can't be seen in the traditional sense because light can't escape from them. However, they can be detected by the way they interact with their surroundings. Scientists observe the effects black holes have on nearby stars and gas to infer their presence. In conclusion, black holes are not the monstrous cosmic vacuum cleaners they're often portrayed as. They're fascinating celestial objects that play a crucial role in our universe's life cycle. Their intense gravity might be fearsome up close, but from a distance, they're harmless. Black holes might be mysterious, but they're not space's cleaning service. Ever heard of the dark side of the moon? This is a term that's been tossed around in pop culture, science fiction, and even music, but it's a bit of a misnomer. The phrase suggests an image of a perpetually dark, mysterious side of the moon, hidden from the view of US Earthlings. But let's clear the air, or rather space, about this cosmic conundrum. The first thing we need to understand is that the moon, like Earth, is a sphere, bathing in the sun's light. So logically, at any given moment, half of the moon is illuminated by sunlight, while the other half is in the shadow, just like our planet. But why do we only ever see one face of the moon from Earth? The answer lies in a fascinating phenomenon called tidal locking. This means that the moon rotates on its axis at the same rate that it orbits the Earth. As a result, the same side of the moon is always facing us. But this doesn't mean the other side is always dark, far from it. As the moon orbits Earth, different parts of it catch the sunlight, leading to the phases of the moon we see from Earth: new moon, crescent, first quarter, gibbous, and full moon. During a full moon phase, the side of the moon we see from Earth is fully illuminated by the sun. Meanwhile, the far side, or the so-called dark side, is in shadow. But hold on, when we have a new moon, the exact opposite happens. The far side of the moon, hidden from our view, is fully bathed in sunlight while the side facing us is in shadow. So, in reality, both sides of the moon have their time in the sun. So there's no dark side of the moon, just a far side we see less often. It's not shrouded in eternal darkness, but rather, it's just a little more shy, revealing its sunlit face only to the vast expanse of space beyond. Scene script. Finally, is there really no gravity in space? Now, this is a question that's been bouncing around for quite some time. It's a common misconception that there's no gravity in space. In reality, a region of space without gravity simply doesn't exist. So, if you've ever imagined astronauts floating around in space because of the absence of gravity, it's time to tweak that picture a little. Let's dive a bit deeper. What astronauts experience isn't zero gravity, but something we call microgravity. This might sound like a fancy term, but it's quite straightforward. Microgravity is what we feel when there's only a tiny, almost imperceptible amount of gravity. This is what happens in space. Now you might wonder, but isn't space far away from any planets or stars? Why is there still gravity? Here's the kicker. Gravity is not just a property of planets or stars. It's a fundamental force that exists everywhere in the universe. It weakens with distance, but it never completely disappears. So, when astronauts are in orbit around the Earth, they are still within the grip of Earth's gravity. In fact, the force of gravity at the International Space Station's altitude is still about 90% of what we feel on the surface of the Earth. But wait, you might say, why do astronauts float around then? The answer lies in the constant state of freefall. An orbit is essentially a continuous fall towards Earth. The spacecraft is falling towards Earth but also moving fast enough sideways to miss it. So, astronauts are constantly falling, but they never hit the ground. They're in free fall, and that's why they appear to be floating. It's a bit like being in an elevator when the cable snaps. You, and everything inside, would float inside the elevator as it falls, because you're all falling at the same rate. That's what's happening to those astronauts and their spacecraft. So there you have it. The myth of zero gravity in space, busted. Space isn't a place where gravity ceases to exist. It's just that the effects of gravity feel different when you're in a constant state of free fall. In space, gravity's always got a hold on you, it just feels a bit different. So, what have we learned about these space myths? Well, we've certainly unraveled some tangled webs of misinformation. The moon landing wasn't a Hollywood production, it was a monumental human achievement. Black holes aren't cosmic vacuum cleaners, but rather regions of space where gravity is so strong that nothing, not even light, can escape. Despite popular belief, there is no dark side of the moon permanently shrouded in darkness. Every part of the moon experiences a day and night cycle just like Earth. And let's not forget, there is gravity in space, albeit weaker than what we're used to on our home planet. Each of these myths, once widely accepted, has been debunked by the relentless pursuit of scientific understanding. This just goes to show the importance of questioning, exploring, and learning. Our universe is a vast and complex place, and it's only through scientific inquiry that we can begin to comprehend its wonders. The cosmos is full of mysteries, but armed with science, we're getting closer to the truth one myth.
Please do like, share, and subscribe to my channel. Thanks for watching.